All right, guys, here we go again. Chapter 9, Stats, questions 4, 5, and 6. Hope you got your paper out because we're going to get started. All right. Number 4, what is the critical value T star that satisfies the condition that the T distribution with the 8 degrees of freedom has a probability of 0.01 on the right of T star? All right. So I was smart this time and I copy and pasted a T-curve on here. So let's figure out where exactly would we have an area of 10% on the right of T star. Well, I'm just going to estimate that right here. So this area right here, yeah, sure, that looks like 10%. That's an area of 10%, or 0.10. Okay. Well, if that area is 0.10, then you should know that this area here, is 0.90, because all that area's got to add up to something, and they got to add up to 1. So this area on this side is 0.90. And why is that important? Well, it's important because when our calculator calculates z-scores and t-scores and all of that stuff for us, it pretty much only gives it to us. We have to feed in our percentile rank, which is always the area to the left of the curve. I think some of the newer calculators might be migrating away from that, but if you still have a TI-84 with the black and white screen, definitely you're going to need to know the percentile rank. So there's our picture. Let's see, we're going to go second distribution. Our inverse T is number 4. And area, okay, so like I said, it's kind of vague. Is it the area to the left? Is it to the area to the right? I don't know. The area to the left is 0.90. Degree of freedom, ooh, 8 degrees of freedom. All right. And if you, oh no, that's it. 1.397. 1.397. So right over here, we got T equals 1.397. Okay, so that kind of answers the question there. What's the critical value? T star. T star equals, type for me, friend. Oh no. Oh no. Things have gone awry. T star equals 1.397. There we go. That's all we need. Right out of the calculator. Number 5. We wish to test if a new animal feed increases the mean weight gain compared to the old feed. At the conclusion of the experiment, it was found that the new feed gave an average, nice, I teach stats, 10 kilogram bigger gain than the old feed, mass gains. T-tests with a proper one-sided alternative, lifts up its pinky when it drinks tea, was done, and the resulting p-value was 0.082. Interpret that p-value in context. Okay, we have, again, another normal curve, so maybe we should just go ahead and figure out where that area is. It's kind of the same thing, actually. It's almost 10%. That's kind of the area we're looking at. Why am I doing that side of the curve and not the left side of the curve? Well, we want to see if it increases the mean weight. So our alternative would be our alternative. We'll did it again. Alternative HA. That would be that mu is greater than, well, we don't know what the null hypothesis is, but we're just going to call that mu naught. Yeah, mu is greater than whatever it was before. Interpret that value. All right, so this is the part that we're looking at. Lucky for you, we have Ferraria's wonderful interprets here. So we're going to do our p-value interpretation. Copy that. And we're going to put it over here. And we're going to put whatever we can here. If h not in context. See, do we have a value? Do we have h not? No. So if we do know it's mean weight gain. If the old mean weight gain was true, then there is a p-value is 0.8082, so that's an 8.2% probability that a sample of size, well, we don't get a sample size, so we'll just leave that at n. Having a, what parameter is this? This is a, 10. Having, well, let's read through that. If the old mean weight gain is true, there is an 8.2 probability that the sample of n having a mean weight gain greater than the statistic value. Well, the statistic value is 10 kilograms. Okay, I can trim this up a little bit. You don't need parentheses. And there we go. So if the old mean weight gain was true, then there's an 8.2% probability that a sample of size n of having a mean weight gain greater than 10 kilograms. Okay, that sounds pretty nice to me. What also sounds nice to me is making this look like an 8-year-old wrote it. All right, there's our 8-year-old. Font size looks huge. Make that look nice. All right, there we go. There's question 5. And finally, at least finally for this video, question 6. You're thinking about using a T procedure. Just thinking about it. Using a T procedure to test hypotheses about a mean of a population using a significance level of 0.05. Not a bad thought. You suspect that the distribution of the population is not normal and may be moderately skewed. Oh, well, at least it's not, severely skewed. Under what circumstances would it be safe to use a T procedure? And that just means that under what conditions is it okay for us to use a T curve or the T distribution for this. And the conditions for using a T distribution would be, well, the skew, or it would be safe to use T procedures if the skew is not severe, which we're sure, and there are no outliers. Okay, So outliers are the big killer for the t-distribution. Even if you have moderate skew, it's okay for you to use the t-distribution, um, but it is not okay if you have outliers. Okay. Um, I should also point out that the larger your sample size is, um, no, I'm not going to point that out at all. We're good. Um, so what condition? Well, this question is asking for make sure there's no outliers in your, I should have put this in here, bold, in the histogram of this sample. Not the sampling distribution, just the sample. If you had a sample of 20, if I made a histogram of those 20 values, if that histogram didn't have a severe skew, if that histogram of my sample of 10 didn't have an outlier, then T procedures are okay to use. All right, that's 4, 5, and 6, and see you next time. Ooh, I didn't boop.